So we're starting our last talk for today. So people who are discussing, if you can please talk outside. We're starting actually. Thank you. So the talk will be about handling media the RESTful approach with a use case with the Kaltura framework. It was initially scheduled at 11 and we'll now do it. So please give a warm welcome to Jonathan.
Thank you. Can you hear me? Okay. Hi, I'm Jonathan from Kaltura. I'm architect in Kaltura open source video platform. And like Jess, I like cats as well. I'm going to talk about lessons that we learned during the years in Kaltura, how to overcome the known limitation that REST API is textual, and how we deal with many media files using our REST API. So video is used today. Media generally is very significant content in the internet. You need it for it's affecting your costs, it's affecting your traffic, it's affecting your storage, it's affecting everything that you do, and of course it's affecting your API. First we have to define the enemy to know what's the problem. I could show you graphs, charts of how media used today in the internet and how it will be used in 10 years. And of course, all the boring charts always show the same. It's always going up, and the conclusion is always the same. You can't ignore media anymore in your application, because media is used today not only in media companies. Media is used today on your cell phone. Media is used today in enterprise companies, in universities, and so on. So in Kaltura, we aspire to do what we call everything video. Everything video means that we are doing capturing and conferencing, transcoding, encryption, streaming, both live and VOD, edge stitching, client-side and server-side, recording, playback, distribution, syndication, and so on. Everything is done in Kaltura using API. Everything is REST API, which is textual. So although REST is HTTP, and HTTP, although it's originally created for hypertext, since the very beginning, HTTP supports media files. We know put action to push files to the server. We know post action that can, post method that able to upload files to the server. Get, you can get progressive download. You can get video or image using get method, and today you can even stream video over the HTTP using HLS, VOD, or live. REST, although it's based on HTTP, it's fully textual. It's an industry standard, and what we usually we use get, delete, post, put, all these actions using textual path, textual query string. If you need a complex data structure, you will need JSON or XML, whatever you choose. Even in the response, everything will be textual, JSON, or XML. Of course, there are simple solutions in the industry. Some providers use put to push files to the server. The problem with push is that it supports only one single file, and you don't have the ability to add to the request complex data structure. Of course, you could use a very complex data structure in the path or in the query string, but it's not designed for that, and it could be very uncomfortable for the developer to push complex data structure in the query string. Another solution is the from data. Again, the problem here, although it supports multiple files, the problem here is that you don't have a native support for complex data structure that like we do in JSON or XML. So I decided to investigate a bit further. So I took 2 specimens of these media providers home, and after 10 years that I'm raising them, I can tell you that they took over my sofa, my kitchen, probably even my brain. Uh, 10 years ago, we started with a very simple solution. The most simple to get media from the internet is GET. You can get the file using progressive download, but usually in the industry standard, the actions to perform on the server are using HTTP methods like put, patch, head, get. What I missed? Anyway, it's very limited list. We have 5 or 6 methods, HTTP methods, and you don't have the ability to add a complex request to the server. What we did in Kaltura is that all our requests are sent using post or get, doesn't matter how it's arrived to the server, and the action itself, what to do about the object, about the service that we are calling, we just added it to the URL, which is a bit different than the classic API, classic REST API, and it's enabling us many different actions. And of course, we support the regular CRUD, create, read, update, delete, and we also added another standard to our standard that's called serve. The serve, instead of returning the object, the XML or the JSON that represent the object, it will return the media that's related with the object. As for upload, we are using a post, of course, and you can post more than one file. And unlike GET that enable you only path or query string, the post enable you to send another option that we have in order to upload content to Kaltura. You just inform to Kaltura what the location of the file, and Kaltura will pull the file for you. Of course, because we're talking about REST API, we have to manage the status of the upload, of the download in this case. The status, if it's failed, succeed, it's progress, and so on. So the serve actions enable us many different content types. Every object in Kaltura, for example, media entry in Kaltura contains few video renditions, few thumbnails, closed caption files, maybe license file, different related files. And file upload enable us to upload all these files. Now, we encountered few issues while using file upload. The first problem with video is that it's huge. We have customers like Walt Disney. Walt Disney, of course, they have large videos, and you don't want to wait 4 hours for the upload to finish, and then it fails 5 minutes before it's done, and then you have to do the entire process since the beginning. So what we did is to support chunked upload. You can upload the files in chunked, and on the server side, we combine all the chunks together to one single file. Another problem that we had is we have different data centers. When you call the API, you don't know what data center you are calling. In fact, one chunk would arrive to different data center, and then you couldn't combine them together. So we just redirect. According to the first server that the first chunk that selected to, all the chunks from this moment on will be redirected to the same data center. In each data center, we have multiple machines. We just shared it with solved it with a shared disk. Chunks may arrive in the wrong order, and we manage it in order to know what chunk to put where. And another problem that we had is that the file upload could take a long time. You don't want to upload the file and only then to do something about it. You don't want to wait a few hours until the entire video is uploaded and only then associated it with a thumbnail or with a video and so on. So what we did to support, to enable you to run the upload and forget about it, we enable you to associate the object, the file, before it's created. So we have some kind of pointer to the file that is not created yet. Using that pointer, you will relate it to the object that it relates to. And later, when the upload will be finished, automatically we will use that pointer to associate it with the object. These are two examples for a common API call. In this case, it's upload token get, which returns XML or JSON representing the object. You can see that the JSON, you can't see that it's JSON because it's, okay, anyway, trust me, it's JSON. You don't see all the screen. We just send the JSON using content type application JSON. Unlike when we are sending files, we will send multi-part form data with the JSON as one of the fields, separated with boundary from the file itself. That's the binary data. I try to save place on the slide, so I don't have a lot of binary data here. Now, if any of you ever tried to implement the API of WebEx or Akamai or other company that deals with media, it could be very difficult. Not easy to implement the HTTP by yourself. And for that, in Kaltura, we generate automatically SDKs in multiple coding languages. In each coding language, we try to follow the standard that the best practice in this coding language. Some coding languages using a string path to represent files, like PHP. Some with file objects, streams, buffer, and Node.js, C#, Java. Each one is different. In some cases, we even implemented sometimes two different signatures of each method in order to support more than one standard in one language. As for file download, we assume that the customer don't want to download the entire content, the entire media, to its application memory. What we, unlike the object that you want it in the application memory, the media itself, you don't want it in the memory, you don't want the binary data. You probably want to do something with it. If it's image that you want to present in your HTML, you can, using our API, instead of returning the media itself, we just return URL that from using that URL, you can download or get the media itself. So every place that we define in our API that serve action, return a media file or any file, instead of returning the file, the SDK will return URL to that file. Later you can use that URL as image source or as to send it to the player and so on. This is I selected the PHP, which is synchronic language. The code is shorter. Here is an example. I'm using a file path, which is the standard in PHP. Creating upload token, which is the pointer to the file that will be uploaded later. The file size is not mandatory, but if we are uploading in chunks, it's very important because otherwise the server won't know when is the last, if the last chunk arrived or not. It's comparing to the file size that we defined in the beginning. And I'm creating the upload token using client, upload token service, add action, behind the scene, everything translated to PHP, to HTTP. And then using the created upload token, I'm just uploading using upload action with the upload token ID and the file path. Very simple, very easy to use. On the other hand, serve action, you can send complex data structure to the server. Our Kaltura thumb params support scaling and trimming and background and many different parameters. I just chose two width and height, which are quite standard in this case. And I just call the serve action with the complex data structure. And what I get in return is remote URL. The URL is the URL that I can use to get the content later. And in this case, I just downloaded the file and saved it to the disk. But I could do anything else with that URL. Now, we have large customers with a large amount of the media, and very soon we understood that just upload and serve actions are not enough. So at the beginning we added a CSV, which enabled you to upload a CSV file, which is, I will talk a bit more about it later. XML file, which is more complex, not so easy for a human to write it, the complex structure, because media entry could be related with a lot of metadata, many different files, thumbnails, media, closed captions, and so on. It's not very easy for a human to write it. We support drop folder. Drop folders could be on the customer servers. In this case, we will see what, using FTP, SFTP, S3, doesn't matter how, we can watch the folders and see what's going on his server, or it could be on our servers, and then the customer our customers are enterprise companies. Many of them use WebEx, so we just added another ability to scan using APIs the WebEx server, and we are downloading the files from WebEx. This is when I implemented the WebEx API. It wasn't easy. CSV, as I said, is designed for human writing. It's supporting very simple properties. Main media file and main thumbnail file, and a few more properties like name. I didn't write all the properties, but basically it's name, description, tags, very basic properties. However, the XML could contain many different related objects. All of them could be in a single XML item. We enable the drop folder to drop the files manually by humans, which is very simple for user just to drop the file, and media entry will be created on our system. But it wasn't enough. Customers wanted to add tags or category or user ID, many different information. So we started to enable them regex to extract data from the file name. But it's, again, not enough. So we decided to support the XML, which is complex data structure with all the related objects, with a lot of metadata, time-related information on the video, and with one different from the regular XML that I mentioned before. This XML could relate to files that dropped in the drop folder. Now, in Kaltura, we saw that we have many ways to upload content to the server, so we decided to associate this content with the files in many different ways. We have asset resource, which is in fact linked to another media that already exists on the server. Drop folder file mentioned, server file, which is integration between our systems. Sometimes one system create a file on the server. Uploaded file token is two different ways that we do that. Webcam, remote storage, which is remote storage that predefined for that specific customer. String, it could be relevant for SRT, for example. If you want to upload SRT, you don't have to upload the file. You can just use string resource, and URL resource, which is, of course, just specifying what the URL, in what URL the file exists. And in order to associate the content with the object, we just define the resource. In this case, it's URL, so I had to set the URL property. And we call thumb asset, set content, and associate the thumb asset ID with the resource. And all these resources supported in all our APIs on all the objects that are associated with content. You can use each one of these resources, and also in the XML. So the XML can use each one of these resources also in order to use each media. Doesn't matter how you uploaded it to Kaltura. We also support publishing the content to external system. Using push, we are pushing the content to the media itself to remote system, and I will show a few examples soon. And syndication, which is publishing MRSS of our content, and the external systems downloading the content to their systems. These are the standards that we support. As you can see, there is no industry standard. But the most important one here is Kaltura, not because we are Kaltura, but because Kaltura exposes all the information that we have on the media, and you can apply XSLT on that media, and using that XSLT, you can apply any different standard that exists in the industry, and sometimes for small companies, that's what we do. Questions?
Any question?
Most of that code was client-side code. Most of that code was client-side examples. What do you have to have on the server side to support that?
All our systems internally using APIs between them.
Okay, but I mean, is there a specific? I have to run the Kaltura server, presumably.
One Kaltura server uses API to talk to another API, so to another server. So.
Okay, so you're saying it's kind of symmetric.
Yeah.
Right. Okay.
Another question?
What do you support as backend storage?
We use our own data center, and we use our own shared disk. It's called Isilon, but it's just IT thing. It doesn't really matter. You could use any disk. We used NFS for many years. It was good as well for a specific amount of content. Today we use Isilon. There are many providers in the market.
Another question?
Thank you.
Thank you, Jonathan.